Lifestyle mistakes destroying gut health. This is part 2. And if you recall, we discussed a case involving Yesenia, a 46-year-old female who I worked with, and she presented with abdominal distension, belching, bloating with, during, and after meals, GERD, alternating stools, undigested food in her stool. And we also talked about some of the eating behaviors that was perhaps contributing to her GI symptoms. This is something that I do. I look at people's eating patterns and their eating behaviors and see how that plays a role in their gut function. So last week, we talked about low fiber intake and how fiber played a role in the gastrointestinal tract and their system and help improve the gut microbiota composition, abundance, and how the microbiome from these dietary fibers can produce short chain fatty acids, which are microbial products that can modulate our immune system, that play a role in maintaining the gut barrier function and the blood-brain barrier as well. So we know that these metabolites have wide range of benefits to the human body. But today we're going to talk about snacking, because this was a very, very, very important element to Yesenia's case. She snacked all day, and I think I recall her eating up to 6 or 7 meals per day, and eating late at night. That was a thing for her. And a lot of people have this problem. Okay. So snacking is such a very popular thing today. A lot of people snack, and we've seen a dramatic increase in the amount of snacking over the last 30 years. And in fact, it's gotten way worse since the pandemic. We eat too much. We eat around the clock, and we have so much available, which is the reason why we snack. But there are consequences to snacking, and it does impact the gastrointestinal system. And that's something that we're going to cover today. But before we go into snacking, it's important to understand digestion, just a very basic overview. Digestion starts in the mouth. It starts in the oral cavity. You have the release of digestive enzymes from the salivary glands, and it involves masticating. So there's a mechanical aspect to digestion, and there's also chemical digestion, which involves the food mixing with digestive enzymes to help support the breakdown of the food. So once it's in the oral cavity, you chew it and you swallow it, becomes a bolus. The esophagus plays a role in helping to move the bolus into the stomach. And once the food enters the stomach, there's a series of reactions taking place, a release of digestive enzymes from the gastric cells, and you also have the release of hormones. And it's important to keep in mind that digestion involves the release of hormones that regulate digestion. So it's not just the act of eating, but there's a hormonal response and influence on digestion, and these hormones can feed back to the brain. So we'll talk a little bit about that, but these hormones play a role in communicating with the brain, and the brain in turn communicate with the gastrointestinal system. So we see this gut-brain axis being established again here. So there are hormones that are released that play a role in stimulating appetite and helping to tell the brain when it's time to eat and when it's not time to eat. So this happens in response to food entering the stomach. And as food is being processed and broken down and mixed with pepsin and protein digestion, the release of hydrochloric acid from the parietal cells, and all of this is happening. Okay, food eventually enters the duodenum. It goes into the small bowel for absorption, and there are more hormones that are released once the food enters the small intestine. In fact, it's no longer considered food, it's called chyme. And there are hormones that are released from the small intestine that tells the gallbladder to release bile, and you also have the release of pancreatic enzymes and bicarbonate because this chyme is acidic. pH needs to change now that it's in the small bowel. Nevertheless, you see food is moving throughout the gastrointestinal tract, and eventually this food leaves the small bowel, enters the colon, the large intestine, and there are vitamins and minerals, water absorption that takes place. There's a series of reactions happening from the oral cavity all the way down as food makes its way down into the large bowel, and then eventually it's excreted. Any waste that needs to come out is excreted. So there's a very elaborate process that's taking place, and every time we eat, this process is happening. You have the release of digestive juices, the release of hormones that are regulating digestion. So this is happening every time we eat. So within the gastrointestinal system, we have endocrine cells, and these endocrine cells can release hormones that regulate digestion, and they're able to enter systemic circulation and exert their effects on the nervous system that way, or they can indirectly interact with the enteric nervous system and the vagus nerve, that is the nerve within the parasympathetic nervous system, and communicate to the brain that way. So you see this gut-brain axis, and this is in the context of digestion, okay? So in previous presentations, we talked about the gut-brain axis as it pertains to the gut microbiota. But we also have things or hormones that are released from the gastrointestinal system that can directly influence the nervous system. But it's also important to note that some of the gut microbes can indirectly influence our hormones of digestion through the release of their short-chain fatty acids binding to receptors, ghrelinergic receptors, and influence in digestion. So the microbiota, our gut microbiome, can actually influence our genes of our hormones of digestion. It's really interesting. So they play a role in our feeding behavior. Can you believe that? It's something to keep in mind whenever we eat food, whatever we eat and the time that we eat, it will influence the behavior of the microbiome. And in turn, that will influence our feeding behavior as the host. So another important aspect of digestion that's not really talked about a whole lot is this migrating motor complex. And the migrating motor complex is a very, very, very important component to the gastrointestinal system, and is under regulation of a hormone called motilin. And when it's stimulated, this migrating motor complex, there's this electrical wave-like rhythmic contractions happening within the gastrointestinal tract. And it occurs in 4 phases. And this type of motor activity occurs every 1.5 to 2 hours. But get this, folks, it starts when digestion and absorption is complete and the intestine is empty of nutrients between 2 to 3 hours after a meal. This is really important. There's consequences to not allowing this migrating motor complex to work, okay? The migrating motor complex, this cyclic recurring motility pattern that happens in the gastrointestinal system, happens during moments of fasting and is interrupted by feeding. So whenever you take in any food by mouth, any food, you are disrupting the migrating motor complex, okay? So when you eat, such as Yesenia, when she was eating 7 meals a day, and those were small meals. She had a lot of smaller meals, which were snacks, and then she had 3 large meals. Whenever she ate any food, a morsel of food, a very small amount of food, it doesn't matter how, just a small amount was enough to interfere with the migrating motor complex. So what happens? The purpose of the migrating motor complex is to help propel food content. So as food is traveling down the alimentary tract, we need this muscular contraction, these rhythmic wave-like patterns to happen to help enhance the clearance of any remnant food. It helps to slough the intestinal wall, and it prevents stasis. of anything inside the gastrointestinal system. Whenever there's stasis inside the digestive tract, it allows for bacteria to ferment, and then it increases, it allows for bacterial levels to increase. So by allowing a migrating motor complex to happen, you're allowing the gastrointestinal system to clear out waste from the digestive system and to keep bacterial levels down to avoid any type of fermentation that can happen within the digestive system. It's a very, very important mechanism in preventing the overgrowth of bacteria in the small intestine, leading to a condition called SIBO, small intestinal bowel overgrowth, which is an abnormal increase in the overall bacterial population within the small intestine. Okay, and this was one of the reasons why Yesenia had that abdominal distension, the bloating all throughout the day. It didn't matter what she ate, she had this bloated feeling all throughout the day, and it was a problem for her. She also had chronic constipation, alternating stool patterns, and so one of the most important things too behind chronic constipation is this motility, the migrating motor complex. It does play a role in chronic constipation as it pertains to irritable bowel syndrome. So this is a very important aspect of gastrointestinal system. And whenever we're snacking throughout the day, you're not allowing a full cycle to be completed. For the migrating motor complex, it needs to have at least, it happens every 1.5 to 2 hours after you eat your large meal. And then within an hour or two, you're eating it again, even if it's a raisin. That's enough to affect the migrating motor complex. It will not happen as long as food is present, because you have a cascade of hormonal responses happening within the digestive system that are telling the body that food is in the system and we need to release digestive enzymes, hydrochloric acid, all of these components of digestion, hormones and digestive enzymes that are required for digestion to take place. The migrating motor complex does not happen. It only happens during moments of fasting. For this reason, this is the reason why we have to allow sufficient time for food to be digested and absorbed, and allow the migrating motor complex to come back around and clean up that digestive system and prevent the overgrowth of bacteria. There's some other benefits to fasting in between meals. It improves insulin receptivity. It also helps with modulating the hormones that signal digestion. So if you eat within a certain window of time and you're fasting during other moments, it helps to maintain glucose and fat metabolism. So it helps with metabolic function, metabolic health, and helping to maintain a healthy balance between the gut and the brain, because the brain will understand that it's not time to eat. So there's no point in revving up genes for digestion, are revving up and releasing hormones that aren't, you're not eating. So, by doing so, you're actually enhancing nutrient uptake to your cells, because your cells are now looking for food and they're more sensitive to your nutrients. So they'll absorb them if you're allowing a certain amount of time of fasting in between your meals. This also improves gut function. By fasting in meal spacing, you are reducing gas and bloating. It also helps to manipulate the microbiome or modulate the microbiome. Fasting increases microbial richness, diversity, and increased levels of beneficial short-chain fatty acids, such as butyrate. And we've talked about the role of butyrate and how it plays a role in maintaining the blood-brain barrier, plays a role in gut barrier function as well. So meal spacing or having moments of fasting in between your meals can be extremely beneficial for your gastrointestinal system as well as your microbiome. So how many of us are used to eating late at night? Or maybe you have a late night meal. Well, it's a common practice. A lot of people eat late at night without understanding what happens, what impact that it has on the gastrointestinal system and just overall health. It's important to know that the gastrointestinal microbiota exhibits circadian rhythm. Gut microbes can change activity throughout the day based on food. Meal timing can affect the composition and function of the microbes, our gut microbiome. So we notice the circadian rhythm, our clock, biological clock, the master clock that's located in the hypothalamus. It's influenced by light dark cycles, okay? And what happens is this master clock is influencing our sleep times, our feeding times, physical activity, our feeding times. It also impacts the peripheral clocks that run our physiology inside our cells and our organs. And feeding times. So a lot of times, and I know in previous presentations, I talked a lot about the composition of our food, the type of food that's needed to modulate the gut microbiome, but in terms of fiber, but nutrient timing, feeding times, whenever you eat, all of this can influence the gut microbiome. The microbiome takes signals from food that we're eating, and in turn will release short chain fatty acids or microbial products that can directly influence the host and influence metabolic processes and so many other things. So the gut microbiome is really in large part not only influenced by food composition, but our feeding time. And metabolic health is significantly influenced by the gut microbiome. And so we can appreciate that we can influence the times that we eat dramatically it can influence the type of microbes that we have in our digestive system. And these microbes in turn can either put us at risk for metabolic dysfunction, metabolic diseases such as type 2 diabetes, or obesity, or can help us be healthy and modulating our immune system and play a role in our sleep behavior, et cetera, or even our feeding, the types of foods that we eat. So when we have shifts in our circadian rhythm, either caused by shift work or late night, many of us are in our gadgets at night. We're allowing artificial light to enter our eyes, or any irregular eating patterns, late night eating, this will shift the circadian rhythm. And it's been shown that circadian misalignment does influence GI diseases. So metabolic syndrome, it affects our metabolism. It also affects how we process, metabolize glucose, and intestinal barrier function is also affected by misaligned circadian rhythm. We see shifts in the microbiome, as I've talked about, peptic ulcer, GERD, irritable bowel disease or syndrome, as well as inflammatory bowel disease, colorectal cancer. This is something that's, if there's any shifts in the circadian rhythm, because you're eating late at night, folks, you're eating late at night, this will impact the physiology of your gastrointestinal system. So if we have regular meal times and we're not eating late at night, we have regular sleeps and we're avoiding light at night, this will improve the overall health of our GI system and helping with better macronutrient absorption of and our digestion of our macronutrients, our carbohydrates, our fats, our proteins, and absorption of these macronutrients. Motility, all of these things, a balanced microbiome. So we have to appreciate that our bodies are fearfully and wonderfully made, and the bacteria of the gut is influenced by the choices that we make. Either you're eating too much frequently throughout the day, or you're eating too late at night. It does impact the health of the gastrointestinal system and your gut microbiome. Late night eating causes physiological dysregulation and misalignment of circadian rhythm, together with microbial dysbiosis. So this was an interesting study. They looked at male mice or rats. It's an animal study, and they had specific dietary habits. And what's interesting, what they found in this study is that the rats that skipped breakfast and had late night eating patterns, okay, they had increased body weight and decreased physical activity. And they found that late night eating was associated with accumulation of fat in the liver and systemic inflammation in peripheral tissues compared to mice or rats that had breakfast and didn't eat late at night. They also found alterations in the composition of the gut microbiome, the gut microbiota of these rats. So this is, while it's an animal study and is just pretty obvious in terms of humans and understanding that the gastrointestinal system is under circadian rhythm, it just makes sense that that we should avoid late night eating, because our digestive system is naturally wired to be at rest at night and be more active during the day. That is what our digestive system, our cardiovascular system, our immune system, everything is on this circadian rhythm. And so we want to make sure that we practice lifestyle habits and dietary feeding habits that are according to our natural body rhythm. So circadian rhythm disruption can affect cell proliferation, which is something really important that's impacting inflammatory bowel disease, cancer, intestinal repair after bowel surgery. So this is really important. I mean, in terms of therapeutic interventions to consider when a person has, say, colorectal cancer. We want to consider the circadian rhythm and making sure that this person or patients with this condition, or even IBD, that they take into consideration circadian rhythm and how that's going to impact the health of the gastrointestinal system and their recovery if they've had any surgery. In terms of getting the best and the most for our nutrients or foods that we're eating, we want to make sure that we're eating within the natural rhythms of our body, this circadian rhythm, where our ability to absorb nutrients is greatest early part of the day. Protein, carbohydrate, fat, digestion and absorption is better earlier in the day than in the evening, because the body is naturally wired that way. That would significantly improve GI health, significantly. Your intestinal barrier function, you're more leaky, you have more leaky gut when there's shifts in circadian rhythm. Okay, if there's any shifts in circadian rhythm that's misaligned, then you start to see an increase in intestinal permeability and a downregulation of those tight junctions, those proteins that help to tight junctions that help to keep the enterocytes intact. So this is a problem. You become more leaky when you have shifts in your circadian rhythm, and so shifting the circadian rhythm, making it more, normalizing it, or at least improving circadian rhythm, can impact the digestive system. Another aspect of this, very easy way of putting into practice a lot of what I'm saying is to practice time restricted feeding. And this has been shown to increase microbial diversity and influence the host metabolism and nutritional status. It's something that it has a multiplicity of benefits. And this was interesting. The study looked at time restricted feeding and how it impacts the microbiome. And they looked at 30 men, and there were 15 in a time restricted feeding group and others in another 15 in non-time restricted feeding group. And what they found, which was interesting, there was an increase in abundance of the bacterial residents. And so fasting is extremely, extremely beneficial for the microbiome and increasing the abundance and bacterial composition, okay? And it's not just any microbes, you're actually increasing the beneficial and commensal bacteria through time-restricted feeding. In summary, this is if you have to take anything from this, avoid excessive snacking. It's really important. The only way I can somewhat give an analogy to this is imagine a wash machine, and you start the cycle and you put in a load of clothes. You start the cycle, and maybe 5 minutes into the cycle, you realize you forgot a batch of clothes, and you go pick up those clothes and you put them in the cycle that had already started. What happens to that cycle? The initial cycle, the initial set of clothes, batch of clothes, don't get fully washed because you're now adding another batch. It's the same for the gastrointestinal system. When you put food into the stomach, it's really important to allow proper digestion to occur. It takes anywhere between 2 to 6 hours for food to exit the stomach. And we want to allow the stomach sufficient time to do its job. But every time you put food into your digestive system, you're not allowing a complete cycle of digestion. So it's important to space your meals 4 to 5 hours apart. Allow the migrating motor complex to occur, a complete cycle. This happens every 1.5 to 2 hours. It prevents stasis within the gastrointestinal tract, and it reduces proliferation of gut microbes in places where you don't want them to proliferate. Avoiding late night meals. Just avoid eating after 6 p.m. No eating. Eat according to your natural rhythms. The natural rhythm of the body is to be most active. Humans were designed to eat during the day and slow down their eating pattern at night. At sunset, there are a whole cascade of events that happen at night. And it's important to note that at night, melatonin binds to insulin receptor. There are receptors, melatonin receptors on a pancreas that tells the pancreas not to release insulin. Insulin secretion is downregulated at night. And the reason why is because you're supposed to be asleep, okay? But if you're stuffing carbohydrates, chips and cookies and snacks at night, you're actually affecting how your body is able to metabolize that food, and it gets converted into fat. And of course, you're feeding the wrong type of nutrition to the gut microbiome. So that's a whole nother. But you want to eat according to the natural rhythm of the body. And humans were designed to be most active during the day. We eat during the day, and it's time to sleep. And so avoid eating too late at night. This supports glucose and lipid metabolism. It helps the microbiome. It's important to keep in mind that if you eat according to how your body's designed to function, then it reduces the risk for metabolic diseases and gut dysbiosis, okay? If you take care of the gut microbiome and help to increase the abundance and composition of the types of good guys and of bacteria in the GI tract, in turn, they will support healthy metabolism too. So keep in mind, your gut microbiota does and can put you at risk for metabolic disease. But if we follow our normal physiology and taking into account when we're eating and how much we're eating, we can significantly improve gut